guys, yeah, I looked over chapter 1, 3, and 4. I found about 2 to 3, maybe 4 main things in each chapter, main topics. Chapter 1, if I look at that, it's very, very, if you've got to read it, of course, but the main thing is that this is your population, right? This is the universe right there. And then this is the sample. A sample is a piece of your universe, okay? Now, when you're talking population, it says parameter. So here's the parameter, we'll call it right there, it describes the population. So the parameter describes the population. And for samples, you have a statistic that describes the sample, okay? Excuse me. So those are the main ideas of chapter 1. Descriptive, statistics, simplify and summarize. And then there's 2 different statistics. Descriptive, which simplify and summarize. And then there's inferential statistics, which these are techniques to study samples and to make generalizations about the population. So when you do your statistics in your sample, you can then infer that information into the population, right? Those are the main things. That's chapter 1. But of course, read through it, you get to know the other things in there. There's difference between discrete and continuous variables. Of course, we know that. Discrete being just, groups maybe, and then continuous being the numbers, continuous numbers. That's chapter 1. Very, very simple. Now, chapter 3, we have a couple of main topics here. Oh, there's 3. We're doing central tendency. So these are ways to measure the central tendency of the data. You have the mean, the median, and the mode. Okay? So the mean is pretty simple. The mean is just an average. So you take your summation of all your numbers, and then you just average them by the number that you have, right? 1, 2, 3, 4, 5. You add them up. What's that? 15 divided by 5. So 3. It's just the average, also referred to as the mean. Sometimes it's denoted with this little character. I don't know really what it's called. But anyway, that's the first measure of central tendency. Hang on, let me close the door. Okay, so that's the first measure of central tendency, is to just get an average of all the numbers. Then the next measure is called I'll do the mode next. That's very easy. When you have numbers like this, there's a list like this. The mode is simply the number that repeats the most. So in this case, 4 would be the mode. Okay? If you had something like this, 1 becomes the mode. Okay? That's all the mode is the number that repeats the most. If you have a number that doesn't repeat, I don't know the answer to that. And then you have the median. The median is the third measure of central tendency. It's called the median. What do you think of when you think of median? When you're driving down the road, right? And you have 2 lanes one way, 2 lanes the other way. This grassy area is the median. So it's the same thing with this. It's the median. So if you have these numbers, and I'll make them different. What's the number in the middle? 10. That's your median. Very simple. Okay. Now, if you have a mixture like this, The median is not 12. You've got to put them in order. So, which is the same thing from above. Anyway, this would be the median, okay, of this series of numbers. You've got to put them in order. That's it. The only other thing with the median is that that's when you have an odd number, right? 1, 3, 10, 20, 21. 10 is your median, right? Because it's in the middle. But what happens when you have a median, even number of data? Let's see, something like this. So we have 1, 2, 3, 4, 5, 6. That's an even number. There is no middle, right? There is no median. Well, in this case, you would take the two middle numbers and average them. 4.5, that's your median, okay? If you had a string like this, there's 6 of them. Then since it's even, there's 2 in the middle, that averages 5 as well. That's your median. That's all there is to it, okay? So we have these problems that we're doing. Problem 2 right here is median. Find the mean, the median, and the mode of these numbers. 3, 6, 7, 3, 9, 8, 3, 7, 5. Okay? So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's an odd number, so we're going to have a number in the middle. So let's order them. I think I did that right. And it's an odd number. Well, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm missing one. 3, 3, 3, 5. Oh, there's 2 sevens. Okay. So you would have to go 1, 2, 3, 4. And then 1, 2, 3, 4. Yeah, so 6 is your median for this one. Yep. It's just the number in the middle. We have an odd number, so there's a number in the middle. That's your median, okay? Question 2 asks for the median. Then we go and get the mean. And that's just the summation of all the numbers divided by the number that you have, which in this case is 9. So I've already done the math. It's 51 divided by 9. So it's 5.67. And I don't know if I'm using this correctly, but I think I am. That's the symbol for mean. So we've got those 2 answers, and then the mode. Well, I'll write it down here, but then we can just go through and see what number repeats the most. Right here, 3. There's your mode. That's it. So with that in mind, I'll let you guys do number 4. Well, no, 4 is a little different. 4's got a series like this, but if you look at the book, can you zoom in on the book? See how it's got your numbers here, 3, 4, 5, 6, 7, 8, but then it's got the frequency. So that's a little different. So really all you got to do is kind of devise your own. Okay, so we have 3 showing up 2 times. We have 4 showing up 2 times, right? That's the frequency. 5 shows up 5 times. 6 is twice, and then we have a 7 and an 8. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 total. So yeah, so now you guys can do the math here. I'll let you guys work that out. But really you just have to translate this chart, this table into a string or an array like this. And then you can do pretty much everything you guys need to do. Well, I'll work it out since I'm here. 1, 2, 3, 4, oh, there's 13. So that would be 6 and 6 on each side. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6 to do the median right there in the middle. That's your median. Your mode is the next easiest one that repeats the most. That would be this number here. So median and mode both equal 5. Median and mode. And then the average, which I've done already. So the total summation of your numbers divided by n. So you have 66 divided by 13. And I'll do that in my head. Not really, I did it already. There you go. That's your mean, the average. Okay? So I went ahead and did number 4. All right, so number 5 is, I might need more paper, Jade, but okay, you have a sample and you have 10 scores, so that's your, it's a sample, and so that's why it's the little n. For the population, you use the big N, right? All right, so part A, assume the scores are measurements of a discrete variable and find the median. Okay, did this already. Oh, I'm sorry, right here's the numbers. So we have 2, 3, 4, 4, 5, 5, 5. I was looking for the data, saying, where the heck's the data? Okay, so here, really it's the same thing we've done. What they're asking for here, okay, yes, there's a difference here with median. Median, we're used to going to the center, which is half of this, 5 and 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So you average the 2 in the middle. That's your median. It's just the average of these 2 in the middle because we have an even set. That's when you have what's called discrete numbers or discrete variables. But what if these numbers were continuous variables? They were denoted as in B, part B. Assume that the scores are measurements of continuous variable. Like for example, right here is the number of kids this family has, the number of kids this family has, et cetera, et cetera, et cetera. You can't have half of a kid. So the midpoint here is 5. But what if this were not number of kids? This is maybe scores, right? If these were scores, then they would be continuous, and then you would work out the median in a different way. How do we do that? The median, oh gosh, yeah, this is, don't really like it. So you would write down all the numbers you have here in sequence. And how many 2s do you have? Well, here's a little box that represents 1 of 2, right? 1. You have 1, 3, right here. You have a 4 and another 4. You have 2 4s. You have to do it in boxes. That's the way the book shows it. How many 5s do you have? You have 3 5s. You have 2 6s, and then a 7. So if you look at this, you're trying to see, how did they explain this? All right. 1, 2, 3, 4. Okay, you still need to come up with 5 because, how did they explain this? Hang on, guys. In this example, the numbers are 1, 2, 3, 4, 4, 4, 4, 6. So they have 1, 1, 2, 1, 3. Then they have 4 4s and a 6. It says here, the median for the distribution is positioned so that each of the 4 boxes at x equals 4 is divided into 2 sections with 1/4 of each box below the median to the left and 3/4 of each box above the median to the right. This one's a little bit more difficult. I know how to do it, it's just hard to explain. So I might come back to that one. But read the book on that one. It's basically a fraction that says the number needed to reach 50% divided by the number in the interval. So I know I did it yesterday. I have it right here. You have to take a third of each of the box 5s and put it on this side. So you can come up with half of the boxes over here and half of the boxes over here. Yeah, I can't describe that one that well. Sorry, guys. Okay. And then, so that's chapter 3 for you. And then chapter 4 is, well, that's chapter 3 except median of continuous. Chapter 4 talks about variability, okay? And variability, we learn about standard deviation and variance. Those are the main ones. So going through here, we have a variance, right, from the measure of central tendency. So we're going to go right over here. I made a few notes. The measure, you can do measures of variability either by doing the range, and the range is equal to your maximum number minus your minimum number. Looks like a misprint. The deviation is going to be your average, or I'm sorry, it's going to be the actual number divided by subtract your average. So the number minus your average. And then the variance is your number minus the average squared. And the standard deviation is the square root of that variance. Those are the formulas you need to go through and learn. So let me do the problems, and it'll make sense. Once you read the chapter, it'll make a little bit more sense. So problem, oh wait guys, I forgot problem number 7 on chapter 3. I just saw that. That one's very, very easy. Problem 7 says, you want to zoom in? There's a sample of 8 scores and the mean is 12. So what's the value of your summation of all your scores? Well, hello, if your mean is 12 and your sample is 8, then that's your formula, right? You're trying to find this number here. So that's 96. So you just multiply the 2. That's what I did here. Okay? Sorry guys, I missed that one. All right, let's go back to chapter 4. And chapter 4, how long is the video so far?
17 minutes.
Oh my gosh. Okay. Chapter 4 is, we've got a few problems. Pretty much if you look at this page here, it's got all of the steps, all of the formulas here. So you've got to read chapter 4 just to kind of understand where all this is coming from. But in essence, what they're asking for is to calculate the sum of the squared deviations, that's SS, the variance, and the standard deviation for the following population. And here it is. So I rewrote it out here, 2, 13, 4, 10, and 6. Since we're doing this mathematically, not so much visually aligning them in order, you can put them in the order that they give them to you. It doesn't matter if you have them in order or not. So when you get the sum of all of them, it's 35. The sum of the squares is the next step. The sum of the squares, so you square each one from above, and you sum them all, 325. You're still trying to get towards the sum of the squared. So when you calculate the sum of the squared, you would take then your summation of x squared, which is 325, and you would subtract the summation of all your x squared and divide by the number that you have, the number of samples, or in this case, population. So you would take 325, the number up here, minus 35 squared, divide by the number you've got. So it's 325 minus 35 squared is 1225. Then you divide by the number that you've got, which is 5. You've got a total of 5. So 325 minus 1225 divided by 5 is 245. That gives you 80. So 80 is the sum of the squared deviations. Then to get your sample variance, which is denoted like this, s squared, you would take that 80 and divide by n minus 1, so the total that you've got. So you take away 1 from 5, you get 4. So 80 divided by 4 is 20. And to get your standard deviation, you just take the square root of s. So the square root of 20 is 4.47. The door for us? Okay, go ahead and pause it. I'll finish on the next video. Okay, I'm waiting for my daughter to come back. But I guess what I wanted to make sure and do is just let you have eyes on the problem so you can pause it and then make sure you can recreate it. That's 3, or I'm sorry, that's 2 from chapter 3. This is problem 4 from chapter 3. Jaden, you ready? This is number 5. I made a mistake there, so this is where I did part A, and then part B I was a little, can't really explain it. I can do it, but it's hard to explain. And then, so just be sure and pause these so you can kind of take a look. Here's number 7, chapter 3. I did it twice. Oh, you know what? I forgot number 22. So number 22 is, it's asking why one measure would be better than the other. Explain why the median is often preferred to the mean as a measure of central tendency for a skewed distribution. The median is better. So the median kind of gets you in the center, right? And then this is more of a mean. And for this, if it's skewed to the left, this is the mean. And then here would be your median here, and this is your mean here. So when you have skewness to the left, your median is more representative of numbers over here and numbers over here. So that's why your median is better when you have a skewed set. Over here, it's just the opposite. If the skewness goes over here to the right, higher numbers, then this is your mean is going to be higher than your median. Your median is a better representation. It kind of represents the tail a lot more than does your mean. That's the best way I know how to explain it. All right. And then here's number 6 that we just did in chapter 4. You can pause it. Get all of that. Here's number 20, chapter 4. Yeah, we go from 6 to 20, so I'll just show everybody the work, and I apologize for my handwriting. But this one is, it's basically, it's the, what are they asking? It's the same thing. You have a set of numbers, 10, 6, 8, 6, and 5. They want, I think I can do it, Jaden, because I'm doing it now, thank you. The mean and the standard deviation. So that's what we got to compute. So there's your mean. Already, we know how to do that already. The sum divided by the number you've got, that's 7. And then the standard deviation is all these steps here below it. So again, you take the sum of the square of each one right here, 261. Then here's the squares of the deviations, SS. That's your formula here. The sum of x squared, which is 261, minus the sum you got up here, 35 squared, divided by n. So the same formula, just run through it, and you come up with 16. Then to get the sample variance, which is s squared, you take that 16 and you divide by 1 less than your n, which is 14, and you get a 4. A nice clean number because you're going to take the square root to get your standard deviation, and that's a 2. Okay. Then 21, oh wait. Yeah, that's It also says on 20 to change the score of x to 0 and find the new median and standard deviation. So I did not do that. But anyhow, so just change the 10 to a 0 and see how it changes. Actually, I did do that up here on my spreadsheet. So I just wrote some formulas. And so here's the same set of numbers for chapter 4, number 20. 2. Okay. I lied. So here. There we go. There we go. Sorry about that, guys. It's this one right here. So it's a 10, a 6, 8, 6, and 5. That's the number 20, chapter 4. And you can tell here, come up with a 7 for the mean and a 2 for standard deviation. You saw the work already. So if you change a 10 to a 0, you do the math, but of course it drops your mean to 5, and it drops the standard deviation to 3. Okay, so I'll let you guys work out the math. But again, that refers to this problem, problem 20. Okay, then number 21 is this right here. It's taking two groups. It's taking these groups here. These are the numbers. We have 15 on each side. 15 samples of older adults and 15 samples of younger adults, and their average score, I believe, representing cognitive skills, problem-solving scores. So we're having to compute the mean, the variance, and the standard deviation for each group, and then which one is more variable or more diverse than the other. And what's said in the problem is that there's greater differences or greater diversity in the older population. So we're going to see if that's true in this set as well. So really, you're going to take the first part of that is to get the mean. You just add up everything and you divide by the number. So that's going to give you the mean of 546 for the older group, the group of the older people. And then I have the samples right here. This is just where I'm getting the average. It's right here. And then I square each one in this column, and I get the sum of the squared, and then I just do the math out here. What you come up with, though, for the, and you can do a pause there too, but it's this one, and this is the younger group. And so the variance for the older group is 469. The standard deviation is 2.17. Okay, so we have a variability of almost 5 and a standard deviation of about 2. The younger group, we come up with the mean of 727, variance of 135, and a standard deviation of 1.16. So we can see the variability is higher in the older group, which is just what we expected from the problem. So that says that the older group has a lot more variance in their cognitive abilities. And the younger folks, they're more cognitively similar, right? That's what this is saying. And also, another interesting thing is that the average of the scores, the younger people scored 7.27, whereas the older group scored 5.46. So it looks like maybe they have better, the younger people have better cognitive skills. So that would be the way to answer this. So I'm going to redo all this more neatly before I turn it in, but I hope that helps. I know it was maybe a little hodgepodge, but I just couldn't give you the, write all the answers out and show you the problem without kind of describing it as well. So be sure and send me a group me message if you have any questions, and I'll help. From what I understand, the assignments due on Saturday, the first day of class, but we'll have an opportunity to make corrections from what we learned in class and then turn it in later. See you in a week, guys.